Good morning, everybody. I want to welcome you to our Tech Talk today. Thank you for joining us. We've got a really special Tech Talk today. I just wanted to go over a couple of housekeeping things real fast. So during this Tech Talk, you can submit questions or things that you want our guest speaker, Heidi, to talk about at the end. You can submit those via the Yammer live event. There's a comment box over on the right-hand side of the screen. So just submit all your questions there. So with that out of the way, I want to introduce Sunaina. She owns a relationship between Cerner and LaunchDarkly, and she's going to be introducing our speaker today. So welcome.
Thank you so much, Alex. Hi, everyone. I'm Sunaina Vadasiri. I'm the Global Account Manager here at LaunchDarkly that manages a relationship with Cerner. If you're not familiar, LaunchDarkly is the preferred feature management in healthcare, and it's really working to improve developer lives and, of course, critical business applications for your organization. So Heidi is a transformation advocate with LaunchDarkly. Super excited to hear her speak, and I will pass it over to her.
Hey, folks. Thank you for showing up today. I appreciate you taking the time to be with us. I was watching your slideshow. I have to say, Between Two Cerns is possibly the best internal webinar title I've seen in a long time. I kind of want to go just for the name. So my name is Heidi Waterhouse. I'm here from LaunchDarkly. I promise this is not a vendor pitch, but I am going to talk to you about how feature management is going to be useful for you. So this talk is called Go Faster, Be Safer. Right now, it's really hard for me to write a talk that isn't just a book report about Accelerate by Nicole Forsgren, Gene Kim, and Jez Humble. It's sort of the scientific method applied to what we should be doing with DevOps and why CI/CD actually makes sense in a business way and in a science way. So if you haven't read Accelerate, I really strongly recommend it. And if you had, buckle in, because we're going to talk about how it applies to Cerner and CI/CD and what you could be doing. If you remember learning to ride a bike, you remember that it seemed really counterintuitive. Your parent or whoever was teaching you would explain to you that if you pedaled fast enough, you wouldn't fall down. However, by the time most of us are learning to ride a bike, we know that if we fall down, it's going to hurt, and usually running faster makes you more likely to fall down. So why would going faster on a bike make you safer? Well, the thing the adult knows is maybe not like all the physics of why angular momentum works, but they know that if you go fast enough, you're less likely to fall down. And so we have this tension between it feels unsafe to go fast because I might fall, and I promise if you go fast, you won't fall. The problem is we are rationally scared. We are not irrationally scared of falling. As a kid, we don't understand why balance comes from going fast. So we are rationally frightened. And let's talk about things that we're frightened of. As a business, we're scared of failure. We're scared of looking stupid. We're scared of releasing things that don't work or break things and don't work. When my air traffic control friend was in training, the trainers used to kick the chairs of trainees who made mistakes. This is an improvement from the actual physical violence that they used to use, like hitting each other with clipboards, which was the method that earlier teams used. The thinking was that if you were scared to make a mistake, you would work extra hard to avoid making them. We call this aversive training, and it works in a sense, but what it actually does is add so much overhead to making sure you're doing your job right and also make sure you're not making mistakes that everything is less efficient. There's a whole nother talk about how unuseful aversive training is, but it's useful to know that we are scared of failure. Another thing that we're scared of is stasis. One of the things that fear leads to is a lack of imagination. If you're afraid that your metaphorical chair is going to get kicked for making a mistake, you avoid risks, and risks are where we keep most of the really interesting ideas. But we're also scared of not doing things. Nothing in our world has encouraged us to believe that coasting is really an option. We know we have to keep moving, like a shark. No company or organization or team gets to rest knowing that they've done something they need to have the next something cooking. So we're scared of being stuck, of being still. And we're scared of being beaten. Related to both failure and stasis is getting beaten. We can be driving our track just fine, and then somebody comes along and passes on our right, and we're eating dust and wondering what we could have done differently. We're scared of that. I think a lot of retailers felt this way about Amazon. Like, they were doing fine and innovating by their own lights, and then, oof, all of a sudden, free shipping and instant delivery sort of changed the world. So how does going faster help with those fears? How does it help us be safer and feel safer? Fast and safe both have very specific definitions here. Fast is continually integrating and testing, and maybe deploying. It's not waiting for long release cycles or major revisions, at least internally. There are good reasons why external changes are complicated. A while ago, I worked for a company that was basically a screen scraper that sat on top of the Medicare software. Now, the people who do medical billing, you may know this, frequently are working in an old green screen system where you navigate by F keys and it's all keyboard based. And the people building this software decided that what it needed was modernizing and a graphical user interface and mouse control. What they didn't do was talk to the people who do billing, who have extremely efficient ways of getting things done. And so they made this mistake of assuming that modern software should look like other modern software. And making that change provoked so much resistance, the software effectively failed, because they hadn't understood that they were impeding fast because of modern. And it took them a long time to figure that out, because the release cycle was so long that they didn't see the customer resistance. They had been building this thing for a year before they released anything, and that's a lot of time to sink into making the wrong thing. If you remember nothing else from this talk, what I want you to take away is that deployment is not the same thing as release. Release is a business decision. That's where we're making the money. That's where people on the outside see the change. Deployment is testing and verification. Deployment is getting your software out to the place that it needs to be. It isn't the same as showing it to the people who are going to use it. And once you separate those things in your mind, you start to have a lot of potential that you didn't know you had before. There are ways that you can work that allow you to go fast without upsetting people who are using the software. Being safe is about making sure that changes don't cause harm and ideally add value. It's really important when we're doing software, especially in a regulated industry, especially when it has impact on people's real lives and not just their social media lives, that we're not causing harm, that we are proceeding carefully and mindfully to make sure that we're doing the right thing. And we'd really like to make money doing it. We need to add value with our changes. Just adding features for the sake of having features is not a really compelling business case. We need to add features and capabilities that actually support the things that our users are trying to do. So when we talk about being safe, one of the things that we need to have is a good feedback loop that allows us to see rapidly what's going on and how it's going. I like to think of this with a gambling metaphor. If you make a small change, there's less chance of it going wrong enough to break something. This is the theory behind fixing typos. Unless you're using certain versions of Word, it's not going to break the document. It's a small change. It's probably safe. You're not going to hold up a release based on fixing typos. Think of it like penny slots. It would take an enormous amount of effort to lose $1,000 at penny slots. You would have to sit in front of the slot machine for hours and hours and hours feeding pennies into it. And it's something where you would eventually realize that you weren't winning and make a change, or you realize you were winning and keep going, but you would be making this small bet. On the other hand, If you're playing at $100 table, it's really easy to lose $1,000 because it's only 10 bets. Like, you don't have to lose that often to lose that much money. So when we're talking about making safe changes in software, I want you to think about making penny bets, making smaller changes, because that makes it much safer for you to make any kind of change at all. I'm in Minnesota, and I think of this in terms of driving on the ice. It's finally spring, so it's a little less like immediate to my mind. But when you're driving on ice, the last thing you want to do is jerk the wheel, because you only have so much traction. And if you jerk the wheel, you're going to lose what little traction you have and be out of control. Instead, even if you're in the wrong place, you just sort of nudge the wheel a little bit. My favorite story about this is about eBay. eBay has been on the internet for a really long time, since the internet was really, really ugly and had a lot of flashing items. And when they started up, their background was bright yellow. Now, eventually, they got kind of more Web 2.0, and they're like, yeah, so it turns out most websites have a white background, and we should definitely grow up and have a white background. And so they switched to a white background, and their users were outraged. This didn't look like their eBay. This didn't feel like their eBay. What is even going on? My cheese has been moved. They were really angry. And eBay was like, oh, okay. You're deeply invested in the yellow background. It's still ugly, just so you know. So what they did was they put it back to yellow. And then they changed the yellow toward white by making it 1 degree paler each day. So every time you logged in, it looked almost the same as what you had seen before, but not quite. And that way, over the course of a year, they got it to the color they wanted without dramatically changing anybody's experience. And we want to be able to answer honest questions. A team at Microsoft told me that code doesn't count as finished until it was tested, released in production, and returning metrics. And I loved that idea. It's not done until it's returning metrics. It's not done when it's tested. It's not done when it's in production. It's not even done when people are using it. It's done when I can see what it's doing. Something isn't safe if we don't know what it's doing. It's just not complaining. And if you have kids, you know that when they're quiet, that's like the most ominous time. And we don't want that from our software either. We want it to be sort of reporting happily. So I think it's useful, if we want to go faster and be safer, to understand our roots, to understand where software is coming from. 20 plus years ago, we started doing extreme programming, which sort of grew into Agile. And Agile's goal was to move faster and deliver the user what they wanted within living memory of when they wanted it. We used to cut gold masters of software, and whatever was on the CD or the disks was what you got. There wasn't a update through the internet option. There wasn't really an internet. So it was really revolutionary when Agile came along and said, what if we delivered something every 3 weeks? Everybody was like, well, that's a lot faster than 6 months. I don't know. It's pretty scary. But it turns out that that has become an industry-leading paradigm. If you release things more often, you get feedback faster, you know you're making the right thing. Then along comes DevOps. And DevOps is a recognition that the experience of software is no longer just the software. It's also the platform that supports it and how it gets out into the world. So the goal of DevOps was to unite product development and delivery so that producing software didn't bankrupt us. And because if you just let Agile people do it, they don't really pay attention to how much it costs to run something. And we wanted to respond to the gaps that a solely user-focused organization found. Because it turns out that if all of your software is written as a user I want to, you don't really make APIs or infrastructure or backends. You make a lot of really nice front-end user-based software, but it takes a backend, it takes structure to support that. So DevOps was a way to recognize that we needed to be doing that too. And then we moved into continuous progressive delivery. Progressive delivery's goal is to get users what they want on budget within a reasonable time while knowing what happens afterwards. We need to know how people are feeling about our software, how they're using it, what's going wrong. And we need to know that as soon as we can, preferably before most people even use it. So that's why feature flags love continuous integration and continuous deployment, because it gives you the opportunity to do small launches without showing it to everybody. And the thing I say about continuous integration is you can't do continuous integration if you can't put broken code on production without showing it to anyone. If you have something that's half written, you still commit it to your code base, but it's not going to activate. It's not going to show to anybody. You can still run all your tests on it, all your integration, but nothing is going to happen until you turn that flag on. And that gives you the safety to do short-lived feature branches, to do testing in production, and to do progressive ring deployment. What I mean by that is, imagine you put something into production and you say, okay, I think this works. It's passed all of the tests that I have, but I need to see how it works in a distributed system, because staging is a lie. It's not a distributed system. It's a facsimile, and we use it to sort of comfort ourselves, but it's not real. So what we need to do is test this with somebody who isn't us, but also maybe not everybody in the world. So you designate a subset of your users to be the test. And sometimes the subset is only people within the company. We have a client who does food delivery, and they do subset testing in a city. So if they're going to roll out a new feature, they say, okay, Petaluma, here's the feature, see how it goes. And we're going to have like the vendors and the delivery drivers and the users are all going to experience this, but it's all geo-gated. So we're not rolling this out across the country until we know how it works. That gives us so much option to make sure that we're making the right thing and that it works the way we think it does. So like I said, I want you to be able to deploy broken code. We don't want to show it to anybody because gross. Like I don't want to show people things that I'm not ready to do, but I do want to be able to commit it and make sure that it's part of the plan and make sure that it doesn't conflict with what other people do. This is part of what we talk about when we talk about trunk-based development, which is this fascinating idea that there basically aren't branches. There's just like the one bunch of code and everybody commits to it all the time. And it works because not everybody is showing their code all the time. So you want to be able to deploy broken code darkly. And you want to be able to turn off part of a release, because sometimes you put something out and most of it works, but not all of it. So I'm going to play a demo for you that my coworker put together about how to do a rollback. Is that playing? Maybe it is not playing. Oh, there it is. All right, so we have this pricing page, and this is what it looks like right now, and we're going to see what we can change to make sure that we have it to work the way it wants. So the features that we're going to change on this page are gated with a parent flag so that they're controlling multiple flags under the parent flag. So the parent flag is called accessibility, and it controls the two flags underneath it. That gives us the ability to say accessibility is on, but maybe not everything under it is on. Or if accessibility is off, none of the things under it are accessible. We have this targeting check. So you are forced to put in a comment. We found that people asked for that, and also confirmation that they're doing in the right environment. So let's go check and see how turning these features on worked. Oops, that's not how we wanted it to work. That's really not how we want it to look like. Yes, okay, we got the blue instead of the green, but no, that's not right. So let's go back to Launch Darkly and roll back just the part that's broken. We're going to roll back the styling, but we're going to leave the change in the buttons. The accessibility parent flag is still on, but we're going to turn off the styling flag. Make a comment. Styling is broken. So I want to make sure that I'm not turning off the things that work, just the thing that doesn't work. Let's go back and check and see if that is going to work out this time. Okay, see, the parent flag is on and the styling flag is off. So yes, it worked this time. We have the blue, and also it still looks like it ought to do. So that's an idea of how you can have partial rollback or fail forward. And then I talked about progressive delivery. I really want to make sure that you understand that one of the things Launch Darkly adds is a really precise way to target the groups that you have, and you can stack them up. So if you say, I only want to target 10% of people, okay. I only want to target people in Florida, okay. And I only want to target people over 70. All right, now all you're going to target is people over 70 who live in Florida, and only 10% of them. Being able to stack these rules gives you so much capability to do fine-grained testing and delivery. For example, you can use rules like that to do what we call entitlements. So if somebody has like a fancy membership, they get more access to your website. Or if somebody has accessibility needs, they can choose which accessibility features they want on or off. When you're thinking about how to implement this, one of the things you have to think about is how much failure is tolerable for your system. It depends on how crucial your product is and how many people are using it. You really need to understand what you're trying to do and how bad it will be if it fails. So if you're, for instance, doing a Twitter clone for pets, okay, probably it's bad if it goes down, but it's not like world ending. If you're doing something that's like medical devices, you have very little tolerance and it's all regulated. Most people are somewhere between those two. It's important for your business, but it's not life crucial. And it's really useful when you're thinking about your tolerances to understand that. So, I missed one. Humans are slow at reacting to emergencies. That's why we have circuit breakers. Nobody is fast enough to say, oh, the kid stuck a fork in the light socket, I guess I will run to the breaker box and turn it off. That's not how humans work. So when we have circuit breakers, they are automated ways to stop something bad from happening. When something is going wrong, the system fails to a safer state rather than causing increasing harm. And I think that there's a lot of metaphors that we can pull from the real world about that. But the useful one that I think of in software is having an operations flag that says, okay, we have an inbound API that's feeding into our database, and we're used to about how much like stuff we're getting in. And all of a sudden, there's a 50x spike in the writes to our database. Now, that might be valid. It might be the Super Bowl or something, or it might be some kind of attack. The thing you want is to not write all of that to your database until you've confirmed that it's good data. So if you have an ops flag as a circuit breaker, you can say, okay, look, if monitoring says we go above, this multiple of our usual traffic, shunt it off into a different database and we'll take a look at it. We'll have the alerts. And that's going to give us the ability to make sure that we have time to react to what we need to react to. We also want to make sure that there isn't a cascade failure. Putting in stops to make sure that failure is contained to one area of the software or operation means that you can keep working at reduced capacity. I think of this as something that frequently happens in thundering herd events when a lot of people show up to try and use a website, like a vaccine website, for instance. One of the things that happens is everybody tries to log in at the same time. And if you're trying to redraw a whole page that has like the map and the availability and everything else, it's a really heavy page. One of the ways that you can get more people in is to let them in with a reduced feature set on the page. You say like, okay, look, my P9 or P95 on this page is over an acceptable level. So we're going to stop drawing the map of where all of the vaccinations are. And we're going to have people click through once they pick like a range. Once they say, I only want things within 50 miles, then we have time to load the rest of the page and present the 50-mile radius instead of the whole map. I think using isolations like that gives us a lot of capability to understand how we can provide degraded service that is better than non-service. Adding control points to your system allows you to react flexibly to problems by turning just parts of it on or off, instead of having it all up or down. This is kind of what I was saying before. Think about where you could add controls to bypass a third-party integration or known flaky servers. If you know that there's like something that happens on your line at 2 a.m., maybe you just want to have a timer that bypasses that section from 2 to 3 a.m. And you want to have rapid rollback. Sometimes we build something and launch it and then realize it's a terrible idea. And sure, you can back it out. Be sure that you can back it out very quickly, because the only thing worse than launching something that's a terrible idea is trying to scramble and not be able to back it out. Like you switched over the database and it turns out the database is not working is a real problem. Needing to redeploy is a slow solution if you are affecting users. So you need to have a plan to do rollbacks. And one of the exciting things about using feature management is that you don't have to redeploy. You don't have to reconnect pretty much at all. All you have to do is change the state of the software that is already out there. When Launch Darkly works, it's sending out what I like to think of as Schrodinger's software. It's on and off at the same time. And the only thing that we have to push to the client is how that should be evaluated. Should it act on or should it act off? Layered access. One of the things that's really important to me is to make sure that when we're doing these kinds of business critical things, we make sure that we're giving access only to the people who actually need it. And it's really difficult to do that if all of your ops people have to have access to everything in order to be able to deploy. So layered access means that the developer may write a piece of code and the tester may evaluate the piece of code, but the only person who can turn it on in production is the product manager or the release manager. That means that nobody has to go back to the developer and say, okay, it's been 3 months, we're ready to turn this on now. And nobody accidentally turns it on because the product manager's job is to figure out when it's supposed to go. So dividing up release into functional roles is so powerful. Abstractions manage change. If you don't have direct connections, for instance, between all your microservices, you can use abstractions. APIs are a great way to think about that. Your interface point is with the API, not the underlying program. If something changes in the program, nothing changes in the API connection until you've checked it and made sure it's okay. Abstractions are essential to microservices and loosely coupled systems, and using feature management to handle your abstractions gives you a lot of capability to make sure that you're doing the right thing. So if this talk was too long and you read Twitter or your email instead, which I know you did because it's right there, and I do this too in the middle of talks, here's what I want you to remember. if you want to release often, and you do, make it safer and less frightening. And by doing that, you're going to increase your speed. And if you increase your speed, you increase your safety. Going faster is, in fact, safer. Making smaller bets is safer than making bigger bets. Doing CI/CD is not an all or nothing position, but it is a way to increase your speed. So thank you for your time. I'm going to look at the questions now, and I would be happy to answer pretty much anything you have to ask. All right, so I have one here that said, you mentioned the subset testing with certain partners, but do you ever consider formal usability testing so that you get feedback from controlled, consistent experiences? What would you recommend for each of these feedback strategies? So if you have, basically, if you're asking me the question about formal usability testing, I think that you know the answer is, it would be great if I could deliver the new thing just to the formalized group. Like your testing team or outside contractor has already identified this group. You'd like to be able to test with them, but you would like it to be a real test. If you test with them on a test server or staging server, you're not going to get all of the subtle interconnections that you would get in a live environment. Like, you can mock up the backend, you can mock up the database, but you're not going to be able to mock up like the weirdness of user data. And maybe your users don't ever enter weird user data, but I would like to thank Elon Musk personally for naming his kid something that has like extended character set. Because I've been saying for years that we are just around the corner from our first emoji named child, and he's really proving me right here. So when I think about that, I think about like, it might not occur to your testers to do that, but we still need to have that available for when we're doing usability testing. So for these feedback strategies, I think it's really useful to put together the release that you want and then release it to your testing group so that they can run people through a formalized usability test. Question: what kind of discipline or framework do you have to build so the sheer number of flags doesn't get so large that you no longer know how they affect each other? As in, if I disable a feature flag, how do I know all the features it'll affect and how? We had a solution with more than 100 feature flags, and no one was confident when flipping any of them on or off because no one person understood how they all affect each other. Oh, I'm so sorry. That seems like a nightmare. So we have certainly found it. So Launch Darkly uses Launch Darkly, and it's useful to know that. So we have several things that we've added to show people where their flags are and what they're doing. Oh, I don't have this connected. We have something called code references, which you connect to your code repository, and it shows you all the places in code where this particular flag key appears. Another thing that we have is we've added, it's a new feature, I'm actually not sure if it's released yet or if it's still in beta, where if you have a dependent flag, like I showed you with the parent flag and the dependent flag, and you try and delete one of them, it will say, oh, wait, you have this dependency relationship. Just FYI, did you know about that? Because we find that's really important. The other thing is, it's really important when you're creating flags to practice good naming and to practice good flag hygiene. So there are two significant varieties of flags. There are long-lived or permanent flags, which are things like your ops flags, your entitlements, like things that you're going to want to be able to turn on and off all the time. And then there are temporary flags, which are things like testing, release, deployment flags. These are the flags that you're using to get the software out there, but once that version is done, you should go remove the flag. Our best advice for that is that when you are coding a temporary flag that you know is a temporary flag, you mark it that way in the flag name. Like we have a permanent tick box so that you can't accidentally delete a permanent flag. But if you say temp, underscore, whatever, it's useful. And then what happens is you code the flag, and then while you're thinking about it, while that's all still in your working memory, you also code how it's going to behave after the flag is successful. And you git stash that, and you just keep it with the code. It's not active, it's just in there, so that when you have satisfied yourself that this flag is successful, it's been 100% deployed for 30 days, is a frequent success metric for a rollout flag, then you go and you commit the new version of the code. So you don't have to think about how you would recreate that. Instead, you're just like, okay, now it's time to turn it over. We also really encourage flag cleanup days, where like every quarter or every 6 months, everybody goes through and cleans out flags that they've made so that they don't accumulate into the hundreds unless people are using that. All right. Question: do you have any strategies for using feature flags when it involves pulling in whole new component versions? If you are pulling in a major version change from a foundational component, can features be used, or are we stuck doing a full redeploy if there are issues? Okay, let me think about that one for a minute. I think one of the things that's useful when I'm doing this is that we have targeting that is sensitive to regex and semantic versioning. So one of the things that you can do is say, if this is compatible with the old version, semantic version, 2.2 and below, or 2.3 and above, that allows you to deal with the fact that not everybody is going to upgrade their major components at the same time. So your flag targeting can be predicated on what version people are using. I'm not sure I answered that question correctly or fully. So if that wasn't what you wanted, let me know. All right, while I'm waiting for questions, I'm going to go through a couple other nifty things. We allow you to do experiments, which means that you're going to be able to set a known good state. You're like, if this is like 55% uptake as opposed to my standard 49% uptake, we'll declare that experiment a success and roll it out automatically, which I think is really cool. Oh, question. You mentioned tolerance for high and low risk for failure. How does the strategy differ between these extremes? If you have a relatively high tolerance for failure, what you can do is roll out more rapidly to more people with less testing. The tolerances are actually about user experience and about like infrastructure. So an infrastructure low tolerance for failure, you have like a multiple cloud scenario, for example, that you're going to need to test with all of the flags for quite a while. You're going to have to let the test soak through a major event and make sure that you have the capacity that you need for overages. And you're going to make sure that if you turn off one of your server farms, one of your clouds, the others can still pick up the slack. If you need that kind of reliability. If you are doing something that is lower risk, then you can be like, okay, I'm going to try this with just like 10% of everybody and see how it goes. And if 10% of everybody are fine for a day, then I'm going to go ahead and continue the automatic rollout, because the edge cases that I didn't catch then are not so drastic. So it really has to do with what the long-term effects of being wrong are. And the more your long-term effects are serious, the more you want to do different strenuous testing. Hopefully that helps.
Okay, I think we're just about out of time for questions. So I guess that'll just about do it. Heidi, thank you. This has been an awesome talk, and I can tell that this content is really resonating with people just by the number of questions we got. So, thank you very much for that. And I guess with that, Heidi obviously is doing other talks besides just this one. You can find them out there on the internet. And Heidi, thank you for all you do, contributing to the industry like this. And any other questions, feel free to drop them. I guess we'll hang out here for a few more minutes. And thank you for joining.
Yeah, thank you very much for having me. And it's been great to see you all. And I think I'm just going to, I will show you what this looks like in code, since we got a couple questions about how that would work.
All right.
So here is the example .NET SDK. What's your programming language? Do you know? Like, probably several, but
mostly Java around here. Though we do have some Ruby and other things. So, yeah.
All right. I know you're in here somewhere. There we go. Java. All right. So you're going to make sure that you have your dependencies. You're going to import the client into your application code, configure the SDK. This is all very standard for pretty much every SDK you use. So then you're going to set up, this is the whole of what you need to make a flag work. Frequently, people have created flags in our user interface, and this is how it's going to look in the code. And we've been giving you the little copy button. I'm excited about that. So that you can say, here's what the user is, and here is what I want to show them. And you can have both Boolean and multivariate flags. So you can have a flag that has like 8 settings. I saw somebody who was using feature flags to do log level changes on the fly. So the log level is like 1 to 7. And if you reboot to change the log level, you might lose whatever weird data you're trying to track down. So instead, it's set by a feature flag, and you can change the feature flag on the fly, and it starts returning the new log level data immediately without a reboot. So I thought that was a really cool use for a multivariate flag.
Yeah, it sounds like it could be useful for more than just adding new features, maybe troubleshooting too.
Yeah. Also, we have something called private user attributes. One of the questions I get a lot is like, isn't this sending people's information across the wire in a way that we don't want to do? And I'm like, no. What we want people to do is, first of all, don't send us any PII. We want you to evaluate it all on the client side. We don't want to see your PII. But if something is private and you want to make really sure it doesn't get transmitted in any way, you can set it as a private user attribute, and then it's hashed and we can't tell what it is. So you can still be selecting and targeting based on it, but it's not going to show in the code what your targeting attribute is. So it's not like social security number here.
Yeah, that makes sense. We were getting some questions about will this be recorded, by the way? While I'm on here, I just wanted to say there will be a YouTube video posted sometime either end of next week or early next week. So be on the lookout for that if you want to catch up. So, and if you're watching from YouTube, cool. I guess I'm telling you something you already know. Let's see. Do we have any final questions? Okay. Awesome. Well, thanks again, Heidi, and thank you everybody for watching. Please do let us know if you like this, and hope to see you next time.
All right. Thanks so much, folks.